Welcome to Navier Dynamics. And in this channel, we'll discuss a lot of concepts about related to fluid dynamics, aerodynamics, aerospace, and lot of interesting stuff related to that. And today, particularly, we'll discuss a very basic concept in maybe the fundamental concepts in fluid mechanics and a lot of things like that. This is one of the concept called dimensional analysis. This is very basic in physics and used in many fields. But we'll just quickly learn this. And the approach uh, I want to go to make it understand is to solve problems. So what I believe is rather than spending so much time on learning the concept, any concept, it's better to start solving problems or do a lot of examples, and then by that we can learn the concept with more confidence and more applications rather than spending too much time on the concept. That's the approach I want to take forward. And today we'll discuss dimensional analysis. This is a very fundamental concept in physics and even in the fluid dynamics or aerodynamics, any of the concept. And the core concept behind the dimensional analysis is whatever equation you have. Example, we have F is equals to ma, or E is equals to mc square, or Schrodinger equation, or any physical equation, any equation which has equality symbol. Example, 5 is equals to 5, or anything which can be any equation which can be related using equality symbol. Dimensional analysis says one thing, that example you consider this as left hand side and this as right hand side. The concept behind this is all the dimension, if two quantities are said to be equal, then the dimensions are also should be equal. So they have all the dimensions of them has to be balanced. So then the dimensions are mentioned in the square bracket. So LHS is RHS. And as we know, we have three fundamental dimensions. We measure all of the most of the quantities in these fundamental dimensions. Those are mass, length, and time. So M is for mass, L is for length, and T is for time. Mass is measured in different quantities, but we'll take kgs here. Kgs, kilos, grams, or you can take anything. And the standard one is kilograms. So I'm taking kg there. Length, we have meters, kilometers, and cubic meters, light years. In astronomy, we use light years, parsecs, and so many other things. And T is for time. We use seconds, milliseconds, megaseconds, nanoseconds, so many things. But standard one is seconds. So what does dimensional analysis says? The dimension if LHS is nothing but left hand side is equals to RHS. If you write this, then the dimension should also be equal. That's it. Nothing more complicated in this. This is the simplest concept you can learn in the dimension analysis, and it applies for any of the problems you want to solve. This is the basic thing. That means energy dimension is equals to mc square dimension. This has to be equal. This is the fundamental concept of dimension analysis. So we'll just solve one of the problem to understand this concept and make it clear. And you can solve a lot of problems. There are so many textbooks. You can solve a lot of problems, but we'll solve particularly this problem, and we'll wrap it up. With this problem, you can particularly understand most of the dimensional concept of dimensional analysis. So there's a question. We'll read the question. Uh, okay, this is the figure P114. Shows the flow of water over the dam. Okay, this is the flow of water over the dam. Okay, good. The volume flow Q is known to depend only upon crust width, acceleration, and upstream height. Okay, there are three quantities here. So I'll just erase this. So this is the water flow over a dam, and there is a quantity called Q here. Q is nothing but volume flow. Okay, nice. Q is volume flow. and it depends on three factors: B, G, and H. Here B is crust width. Okay, there is a crust here. You can see. So this is called in a dam. This is called a crust, and they gave its width. Okay, and they gave G. We all know G, acceleration due to gravity, and H is the dam. Okay, H is the height of the dam crust. Okay, this is the width of the dam crust, and H is the height of the dam crust. And they have also given, it is further known that Q is proportional to B. So this is very important. Okay, this is height, and they have given Q is proportional to B. They have given a relation. What is the form of only possible dimensionally homogeneous relations for this flow rate? So basically, they are saying Q is somehow related to B, H, and G, and we don't know how it is related. How it is related, but they have given a clue here that Q is proportional to B. It says Q is proportional to P. And in physics, in mathematics, generally we know when you open the proportionality, we get a proportionality constant. Let's say that as C. So Q is CB. They have also said it depends on the acceleration to gravity and the height, but we don't know how it actually depends. But with B, we are clear that it depends with the power one. But with acceleration to gravity and H, we don't know how it depends. So we'll just write G power A and H power B. We don't know on which power it depends. Example, if you have E is equals to MC square, here C depends on square of E depends on square of the C. But here we don't know what Q depends on G and H. So we'll just consider Q is equals to C, D, G power A and H power B. Okay. Now here to find this A and B, dimensional analysis comes helpful in these type of problems. With dimensional analysis, we can just solve it very easily. Since we know that we are equating two things here, left hand side and right hand side. And from dimensional analysis, we know that their dimension should be equal. C, D, G power A and H power B. That's it, simple. If you just solve this, you'll get the answer for A and B. So let's solve it first. Here, Q they have given as volume flow. Volume flow rate. If you see the volume flow is dependent on volume flow rate. That means I can write Q as volume by time. It's the amount of water flowing per a second, right? If you see here, Q is nothing but, example, we'll get a separation here. It is the amount of water passing through this particular volume, V. I'll just use a different marker here. Okay. This amount of water flowing this within this particular volume per second. That is what Q actually represents. So I'll write Q as volume by T. And if you know that volume has dimensions of L cube and time has S. So it's L cube S power minus 1. So if you write MLT, it does not have any units in mass. So M is 0, L is 3, T is minus 1. So this is the dimension of Q, basically. Now we don't know the dimension of the right hand side. I will just find it easily. Since C is a constant here, it does not have any dimension. So we'll just take it out. B, G power A, H power B. As we know the dimension of B, its length, because B they have mentioned as width. Width has a dimension of length. So we'll just keep it as L power 1. But the problem is here we don't know what is the dimension of G and H power A. But we know the dimensions of G. The dimensions of G are meters per second square. As the the acceleration dimension is velocity per time, velocity is meters per second and meters per second square. So here we can write as m power 0, L power 1, T power minus 2. So I'm just writing this directly as L L t power minus 2, and there is a whole power a. Next, h, if you see, h is nothing but height. H is nothing but height here. And height has a dimensions of meter. So h is nothing but height, which has dimensions of meters. Meters is nothing but L power 1. So I'll just replace h with L, and there's a power b here. So if I just multiply all these things, c is just a constant. It does not have any units, so that will be c. C will be remaining. And there is n L here, L power 1 plus L power a there. If you see, it's 1 into a. Here there is a b. So L power 1 plus b. And and t, if you see, it's minus 2a. If you multiply these two, and that's it. T has nothing. So if you see the left hand side, it's q. It's L t power minus 2. L t power minus 2. And right, if you remove this, the right hand side has L power 1 plus a plus b. T power minus 2a. That's it. We are done. Now this we have left hand side, right hand side given clearly. And the left hand side L is power 1. So 1 should be is equals to 1 plus a plus b. It's just an easy algebra question now. And minus 2 is equals to minus 2a. That means, okay, it's okay, sir. It's t power minus 1. Sorry. Q has the left hand side is minus 1 since Q is volume per time. So it's minus 1 there. Minus 1, minus 1. So this will be changing here. So minus 1 is equals to minus 2a. Minus minus gets cancelled. A is 1 by 2. So we got A as 1 by 2, 0.5. And if you substitute A here, that is 1. And volume has L cube here. So sorry, L cube here. If you just replace that with 3, because we are left hand side is Q here. If you don't forget it, 3. 3 is equals to 1 plus 1 by 2 plus b. 3 minus 1 plus 1 by 2 is 3 by 2 is equals to b, and b you have 3 to 6, 6 minus 3, 3 by 2. So you have both b and a here. Those are the two unknowns we wanted to know. We see in the first place, we wanted a and b. We have both of them now. So now you can write q as c b power 1, g power 1 by 2, and h power 3 by 2. So q can be written as something constant c, b, root g, and it's a root of h cube. So this is the relation we need for finding q. This is how we solve the problems of dimension analysis or any problem related to dimension analysis. If you don't know how to form a relation, just do the dimension analysis whenever required. Just equate the dimension. Just remember that when you equate two things, the dimension should be equal. And we did the same thing here. We just equated the dimensions of it, and we obtained the relation as follow. Q is C, B, root G, and root H cube. So that's the required answer for this question. B and root G, root H cube. This is how you solve the problems of dimension analysis or any of the problems. This is the basic concept I wanted to teach. Teach. I wanted to present today. I hope you like the content. We'll solve many. We'll try to do as many as concepts in aerodynamics, fluid dynamics, and many of the concepts in aerospace. And a lot of interesting videos we follow through. So if you like it, don't forget to subscribe it and support this channel. And we look forward. We'll look forward for tomorrow. Thank you.